Oh, g'day champions. We've got a, I think it's a 63 Princeton here. We'll know more once we open it up and have a look at the date codes on the components and whatnot. It's pretty rare that I get amps of this vintage in. It's becoming more and more common as years go on. What I think is happening is some of the local techs will only touch these kind of vintage amps. They won't look at anything modern, but they're starting to maybe take in a little bit less as they're eyeing off retirement or whatever. So a little bit more is finding its way to me. It could be something to do with the YouTube channel as well, just getting the word out there a bit more, which is great. But most of the stuff I work on here, and most of the stuff in the local market out here in Western Sydney is late 80s, early 90s and beyond. I do enjoy working on the modern stuff, the surface mount stuff. Even when you've got no schematic, no documentation, it's a bit of a puzzle, it's kind of fun. A lot of these older amps are just drifted components, dodgy previous work, and just things that need a bit of a clean up. Just stuff that's worn out, like worn out pots, that kind of stuff. Now the owner of this amplifier's had it since, I think he said the early 80s, and he's a veteran of the Aussie music scene, and he's worked with some absolute legends. And he gave me carte blanche, if you will, to just make this as solid as possible. In his words, do to it what you would do if it was your own amplifier. Now, I really enjoy it when they give me that kind of trust and freedom. We don't have to worry about the pedantic, you know, every cap's got to be original and, you know, somehow make it all as exactly as it was the day it was built, but somehow make it not catch fire. Now, those two things are usually mutually exclusive. We don't worry about stuffing caps and all that kind of bullshit on this channel. We just make it as solid as we can. We service working musicians that need a reliable amplifier because it's a tool. They don't want to have an embarrassing situation where an amplifier starts humming or starts smoking on stage, because they won't get hired back for another gig, will they? And a lot of these other techs, you've got to question their motives when they replace one capacitor in an amplifier from the 60s, and then, oh, surprise, surprise, another one fails in a couple of weeks. Guess what? Another bench fee. Oh, then the next one fails. Guess what? Another bench fee. I think that's a bit of a dishonest business model. Around here, we do the whole job, we do it right, and if I don't hear from a customer in 10 years until it needs its next service, then that's kind of the goal. It's probably why I don't own 3 houses and 2 cars, but anyway. So let's crack this one open, see what we're dealing with. We'll probably do a two-parter, assessment video, then repair and demo. As we normally do, keep it short and sweet. All right, so first things first, missing handle. We'll replace that with a new one. The genuine leather ones are kind of weak. The leather's not great quality, and the non-leather ones, the fake ones, aren't that much better. But what I might do is talk to my guitar strap manufacturer, DSL, in Sydney, and see if they can make up some ones out of some nice heavyweight leather and like double it up and stitch it extra strong. That might be something I could offer on my website, some upgraded ones, because generally the brackets are fine. It's just the handle strap itself which gets torn to shreds. Now, I don't know about you blokes, but the first thing I noticed when I turned this thing around was the step down transformer's been screwed into the base of the cabinet. That's a little bit unfortunate from you know, originality point of view, because we've got some screw holes and stuff there and evidence that it's been used. And you notice there it says 60 cycles. There's a reason also that is stated on the back of pretty much all amplifiers, or it should be anyway, because the transformer core size is pretty critical with respect to the frequency of the mains. If you've got a tiny little transformer, it may be adequate at 60 cycles, but it will saturate and overheat at 50 cycles, 50 hertz. So even though you're powering it with, you know, even if it is bang on 117 volts on the secondary of that step down transformer, it doesn't change the frequency, so that could be overloading the little 60 hertz transformer that's in there as well. The speaker cable's got a fair bit of like mildew on it, which isn't fantastic. We might be able to clean that up, but I'd prefer to just replace it. So we've got the wrapped up remainder of the mains lead there, and also a ground lead which goes to the chassis and to the casing of the step down transformer. We've got a bit of a mix and match set of screws there on the back covers. Some with cut washers, some without, and some missing altogether. Some of the screw heads are a bit reamed out, making removal difficult. This often happens because the tech previously used a drill. I like to remove them by hand where I can. But we'll remove both covers because we're going to install a new power transformer, so he doesn't have to deal with the weight of the step down. Alright, so checking out the tube combination, we've got a, don't know what, 5x3 of some sort. Can't see any branding on the base of the glass at all. Nothing on the top. There's the camera. Don't know. We've got a Hammond 6v6 GT, made in the States. Is that a date code there? 64. Maybe batch number 312, not sure. 26th week. If that's the way it works. Got a large black plate 12AX7 AWA, which is a Australian manufacturer. Amalgamated Wireless Australasia, I believe. That was missing its cover. And the last one we've got, hard to read, but I think that's another Hammond 7025 from the US of A. Now I'm not sure if this is the original driver or someone's put a 12-inch in at some stage and gone back to a 10, because you can see the sort of footprint there where it's the cork gasket's taken off a bit of paint, or left some cork behind or something, and there's some extra holes at a larger diameter. So I've got a feeling that maybe they tried a 12-inch driver and either didn't like it or it failed and they put the original back in, because I'm pretty sure this is the original. Again, you got the recurring number 64 there, so this is all pointing towards a 64 model. And we can see here the half the label's missing. It's almost like someone's tried to peel that off. So we're missing the production. I guess that's normally where they'd say the production year over here. Alright, so here's what we're dealing with. We've got a bunch of extra holes drilled for mounting and the cable securing clamps. So we can't do a lot about them. I guess we could plug them and sort of try and stain them to sort of cover them up. But again, the owner's not too fussed about the, you know, pristine originality of this amp. He just wouldn't mind it being 4 kilos lighter and, you know, just be able to plug straight in. And also have no safety concerns with the ground wire and stuff. So we'll just, that's got the original 2-prong cord, so I'm not sure if it's got the ground death cap in there or not. Still got the switch, but someone might have disconnected that in the past. While we're there, we'll just check the fuse rating. That would be a 2 amp if it was running on the step down, and it's a F2A, fast blow 2 amp. So when we change the transformer, we'll have to change that as well. We'll change it to a 1 amp, probably slow blow. But for now, we'll get the chassis out so we can have a look at the guts and go from there. We don't need that ground wire, so I'll just disconnect that. Looks like an aftermarket. Someone's drilled a hole and just used a sheet metal screw into it. So this has just got Kep's nuts on the inside. It's before they started using the threaded inserts pressed into the chassis. So you do have to reach inside and stop the nut from spinning free as you undo it. All right, shears free. Just get the cabinet out of the way and we'll look at that later. All right, not a lot to these little buggers, is there? You can see the core size on the transformer there. It's pretty small. You guys in the States are used to that, but ours have a stack almost double the height. Got the original cap there, Astron branded chassis mount. So that's a 3-section 20 microfarad, 450 volt. It looks like all the original sockets still in place, black plastic, or I don't know if it's Bakelite. It got some little chips taken out there. Something's impacted the socket at some point. And on the chassis here, we've got numbers which suggest 1963 manufacturing. You Fender nerds probably know more than, well, definitely know more than me, so maybe chime in. Not sure exactly how these numbers work. Again, 606 you see on a lot of stuff, so I don't think that 63 means anything. I'll have to look up how to interpret those codes. I do almost every time, but like I say, I don't get these vintage amps every day, so my memory's terrible at the best of times, so I often have to re-look up how the codes are deciphered every time one comes in. And here on the output transformer, we've got 606 238. Alrighty, so a quick look. Straight away you can see that screen node dropper is burnt out. So we've probably got a bad output valve. As you can see here, on the ground switch does nothing. It's only used as a terminal point. Someone's removed the death cap, so that's good. That's what we want. You got the active going to, oh well, 2-prong plug, so it could be active or neutral, going to fuse ring, so we'll remove that, we'll swap them over so that the active comes to the fuse tip, and then you go off to the power switch, and then from the power switch to the transformer, and the neutral is just always attached to the transformer. We'll be replacing the cord and the plug with a molded one-piece thing with the safety prongs. Here's an example of that there. You can see if the plug's like out a little bit from the wall and the guitar string or something falls in, it touches this area, which is insulated, and only the very tip that engages with the contacts is bare, and it's all one molded piece, like watertight, and no one can get in there and play with it, and it also has good strain relief, so that's what I replace everything with. And yeah, it's just a PVC cord. You can get pretty versions of it and stuff that cost an astronomical amount, but when you put a dollar figure on it, more often than not, the musicians just go for a standard plug. So here's the naughty screen node resistor. Someone's already replaced this at some point, so maybe the valve's gone short. They thought, oh, this resistor's burned, let's replace it. So they put a carbon film in there, looks like a 2-watt. And then that promptly burned up as well. So yeah, there's deeper problems that aren't solved by just replacing resistors. Generally, resistors are just a sign of another problem. When one burns up, it's because something's drawing too much current across that resistor. So it burns, the fault still remains, you replace the resistor, the new one just burns as well. So you can sort of think of them a little bit like, in that one respect, as being a fuse. They're indicative of another problem, not the problem itself. All right, we've got all original caps in there, some dated 62. So probably older stock from when it was produced. We've got some mustards in there, which is interesting. I think they may have been replaced. It probably had the yellow astrons. They all started leaking as they do, so someone's replaced them with mustards probably reasonably early in the, well, comparatively in the amp's life. We've got a missing screw there to the chassis, so we'll be replacing them. I've got some sheet metal screws that do the job. Looks like this area's never been touched since the factory. It's the original cap there, so that's never been replaced. TC, so is that the 20th week of 63? If anyone can enlighten me, please. WG, is that the assembly person? I don't know. So it looks like whoever worked on this in the past is a tech after my own heart. They've done all the similar stuff I do, removing the terminal points from the transformer mounting hardware, which is recommended. One curiosity here though is it looks like these caps have been like cut off and then resoldered to the old leads. I don't understand that, because they look like the originals too. They haven't been like rewrapped like we discussed in the intro, but not sure. Maybe they've been pulled from another amp and put in this one. No idea. But again, like with the whole point with eyelets is they're easy to rework. So the only reason you tack stuff on other stuff is because the amps are time-consuming nightmare to disassemble to the point where you can access the original solder joint. But here it's just staring you in the face, brother. So the mustards are a good test of Sony's colour balancing and colour representation. They look a little bit green in this photo, but they're sort of like a pale beige almost in real life. So I'll have a bit more of a play with the Sony colours and LUTs and all that jazz, but at the moment I'm working about 15 hours a day, so no time for that shit. Sometimes these develop little cracks around here at the end of the cylinder, and that lets moisture in and they start to leak as a result, but these look in pretty good nick actually, so they're probably all fine. We'll test them anyway, but chances are they'll be a-okay. Just do a quick test of some of the resistors, check for drift. 1.51, that's good. 103k, that's good. 102.8k, that's great. 56k, that's great. And 56.7k, that's great too. These are remarkably intolerance resistors. Normally they're way out of whack. 1.03k, 1.12 meg, test the bias feed, 226k, 227k. We're about 15k on the dropper there, which is pretty common. We'll know more once we remove that capacitor, but this is just a initial thing. Pretty much, despite the look of that resistor, it's sitting pretty much bang on 10k, 10.1k, which is surprising. Normally when they look that bad, they're either completely open circuit or heavily drifted in value upwards. Yeah, whoever was in here knew what they were doing. They've got like strain relieving kinks on the components they've replaced, that kind of thing. Now up here we've got what looks like one of the original film caps. The solder joints look factory. So that's one of the blue molders. They rarely go leaky, so might be a bit of a shame they've replaced them all in this amp when they maybe didn't have to. What often happens in these amps, particularly in this area, you've got your bias supply there and you've got your plate supply there. They're very close to each other, and you get leakage in this area here. People often misattribute that to these caps leaking. and they replace them or just replace all of them in the amp, when actually it's the board itself that's leaking. So when they rework this area, they might heat up this joint and drives a bit of moisture out. You know, I've talked about this before, Lyle's talked about this on his channel. That makes the conductive problem temporarily go away, so they think the new capacitors have been installed that have done the job, but what they've actually done is heated these eyelets here. That's driven the moisture out, reduced the leakage, but then it slowly comes back again. So you need to sometimes soak with alcohol, clean, heat, evaporate, repeat that cycle dozens of times, and then slowly the problem gets less and less evident. The other thing to do with all the old Fender amps, particularly these ones that don't have any coating on the board, is just don't store them in your basement, don't store them wherever it's massively humid, and make sure you just run them once a week just to drive out any moisture with a bit of warmth, and that generally addresses the problem. It's mainly when they've been sitting in a basement or something, somewhere humid, for a long period of time without being used, that is most evident, and that can manifest itself as dragging the bias supply upwards towards zero and beyond it, and red plating your output valves. Further upstream, it manifests itself as just sending the next gain stage out of bias and distortion, cut off, that kind of thing, so you get some strange behavior. It can also manifest itself as like crackling, strange rushing water noises through the board. Now up the bias board, we've got cap dated 63, and it looks like all original components here, so I'm guessing this all this dating is putting it somewhere in mid 63. We've got the original input jacks, looks like all original up that end. All the original pots. Nice and clean. No brass plate on this one, so that might date it as well. We've got a strange little silicon diode hiding down there, which looks original as well. It's funny that it's actually got black paint on the eyelets for just that component. That's strange. Maybe that is aftermarket, not sure. But it's not the selenium rectifier one, so again, that might have some implications as to the actual date. So now it's time to get out the chassis iron, get it heated up, get it nice and angry, and start some work, champions. So we'll start just rip and tear all the bits that we're going to take out. And of course, everything gets returned to the customer in a nice little Ziploc bag there. So if they ever did have a pedantic buyer in the future, if they did want to sell it for whatever reason, their personal situation's changed or whatever, they could do it with all the original parts, and I do that for every job. So let's get to work. Click. Tell that's never been undone from the factory. That's the chemical bond between the two metals. Letting go. Anyone that's worked on engines has heard that. Just carefully lift that and have a look. Okay, so we've got the shared lead between the two. So the back in the day, the leads were long enough you could actually pass it under and use it as a terminal. So replace that diode, because that's a critical part. That's the bias supply. We don't want to play with old... Oh, and look at that. The other end just snapped off. And you can see there the discoloration, like maybe that's been arcing. So, yeah. Glad we looked at that. You can see down there the lead's just fractured within the solder dome and snapped off, probably from vibration. So that would have had no bias supply at all, or at least an intermittent one. And this is why you got to check everything. If we just assumed that was okay, we would have had some problems. We would have found them pretty quickly, but still, just one less thing to worry about. Now we'll replace this 100K with a metal film, because again, there's no tonal advantage, and we're just after reliability in that area, being the critical bias supply. Working around a camera is not fun. It's been a while since I've done an actual working video. It's usually me just showing the finished result, but had some people comment that, oh, we never see anyone actually doing the work, we only see the finished product. I don't know if they were implying that maybe someone else is doing the work and I'm taking credit for it or something, but if only. Might have an actual life if that was the case, but no such luck. I'll just remove this board, just get it out of the amp, makes it a lot easier to work on. We've got the solid core cloth wire there, so there's only so many times you can bend it. So that cap lead there is actually the long lead that goes all the way to the chassis ground there, so I'm going to cut that off at the cap body. Starting to remember why I just do the videos on the finished product, because working around the camera is the biggest pain in the ass. Alright, so removing the board just gives us the opportunity to clean under it. Just check there's no big solder blobs or anything too, so that's handy. Just prep these leads for when we reinstall the board. Now, one other area for improvement on these amps, which we'll do with the new transformer, is at the moment it's just got an unbalanced heater supply. So one terminal goes to the chassis right there, and the other terminal goes off to a string of heaters. And at the valve sockets, you got pin 7 grounded there. And on the preamp sockets, you got pin 9 grounded and pin 5 and 6 tied together to the 6.3 volts AC. But what you can do is set them up so they're balanced. So they're basically 3.15 theoretically, ideally 3.15 volts AC per line, and out of phase to each other, so when you run them in a tight twist they cancel out the hum. So that's another way to reduce your background hum levels. So because we're removing the transformer, I'll just desolder all of them. I won't cut the leads because I want them to be as long as possible in case someone ever wants to reinstall this transformer for historical sake. For that, I'll remove the mains lead because it's getting in the way. 5 volts for your rectifier heater, your HT, 6.3 volts, the rest of the heaters, the primary side of the power transformer, those black leads there, and we'll have to get our big man pajama soldering iron out for the chassis connection there. Got my handy dandy little pliers there, YTH205, everyone always asks about these. I think they're sort of a generic thing that various different brands rebadge, and it makes that much easier to remove, the little cable glands. Alright, so I thought I was recording. I removed all these parts. Trust me, I removed them. You can see they're not there. I'm still getting used to this Sony piece of shit. It's a real pain in the ass, actually. I miss my panny boy. It's a bit to get used to a new camera. It's kind of one of the most annoying things in the universe. Anyway, I cleaned out that eyelet a bit. I got some flux sprayed underneath and just got rid of the slight blob of solder that was under there. We'll clean up this area with some alcohol. There is a bit of schmeal on the board, but it's not too bad. It's mainly dry dust, no slime or anything. So we should be able to just clean it up with a long bristle brush. We've removed the burn resistor. We'll clean up those eyelets as well. Then we'll start looking at getting the big man pajama soldering iron out and removing this connection over here. Now we'll leave this cap in place, and one very handy thing on this and many other Princetons is these two holes here. Now I'm not sure what they were ever for because I've never seen them used for anything, but you know what they're good for? A tag strip to go from here to here, and we can mount 3 axial caps from that tag strip over here to the original points where they'd normally connect to the capacitor on the chassis. Sorry, words aren't working for my brain at the moment. Lots of old leads here. I don't like them when these techs just cut parts off and leave the old leads in the eyelet. Like, how hard is it to remove a fucking lead? Honestly, it's not a multi-layer circuit board where you've got 50 billion connections to it. It's just a bloody eyelet board. Just remove your leads. Always got to find something to bitch about, don't I? Just other lazy techs. They're my biggest gripe these days. Lazy other techs and me having to clean up their bullshit. We've got a little bit of cable greening happening on the output transformer wires. Hopefully it's not too bad, but clean it off with some solvent, see if we can just reuse it. I don't want to be replacing that wire because really you'd have to replace the transformer because the wire disappears into the windings. So hopefully it's just a bit on the tip there, but we'll maybe strip a little bit off and see if we can get any clean wire there. Remove this dropping resistor too because it was out of tolerance. Again, there's no tonal magical fairies to be had with these being carbon comp. The leads folded over a little bit. It's a bit difficult to remove on that side. And again, I think we've got some old leads there, have we? No, they're just those two neighbouring wires entering the eyelet at that point. And that is that one there. So this is probably the sort of time consuming part with vintage amps, just cleaning up everything. Repairing the old solder joints, getting rid of the old leads, the dodgy old work, that kind of stuff. They're easy to work on, but for some reason people still take a lot of shortcuts. I don't know why. Just I get the majority of the solder out with the solder sucker, and then just soak up the last bit with a bit of braid because you can get right in there, you know. right up in it too, so what's it. Now, if the leakage in this area is still a concern, one thing you can do is just fly this connection up in air. I've seen some people get like little 2-terminal tag strips too, and just solder one terminal to the eyelet, and then have the other terminal holding these. Either method is okay if the cleaning the board up isn't adequate. Ideally, like if you're making a clone or something, I'd not go with the fiber board at all. I'd go with a Garolite or a you know, a fiberglass, and use some turrets. Just disconnect this multi-section cap, and we'll lay these terminals flat to allow the new axial caps to pass over, and as a result we won't need these original wires either, so we'll take them out. Bump the camera for the 500th time. Yeah, I was cleaning the solder joints up before, and then it only just occurred to me, hang on, I don't even need those wires. So like I said, I never thought I was smart. You can hear that some of those solder joints on the eyelets are sort of like sizzling as they cool down, so that indicates there's probably some moisture in the board. We don't need this connection anymore. We don't need any connections to this capacitor, because it's just going to be out of circuit and just left in place purely for cosmetic reasons. However, we'll clean up the scabby solder, we'll make it look presentable, you know, get rid of all the crusty old flux. Right, and there we have it. So that's pretty well flush with the inside of the case, inside of the chassis, I should say. So that's just purely there for cosmetics. So from the outside it looks like original, and we don't have a gaping hole that we've got to plug or anything, but the new caps will be able to pass over it without touching it, so that's good. Moving on. Okay, because we want a ground connection to pin 1 and 8, we'll just remove it. Of course it goes through pin 7 first, doesn't it? So we've got to take it out of all the others instead of just snipping off pin 7 if it approached from the other side. But you know, and then there's the brakes. Just feed that through and see if we can get it down low enough that it's not a risk of touching that once we set up the heater to be balanced. This is just that sort of braid wire that Fender use for a lot of their ground connections, just bare braid. Not sure why they chose that, probably so they can heat it with a chassis iron without it you know, melting the jacket or anything. Problem is it gets tinned and then it's not flexible. So you kind of need to heat it just to bend it, otherwise it just breaks after a while. Same deal with Mesa Boogies. Mesa Boogies use it on all sorts of shit, like every ground connection. We don't need the chassis connection there to pin 9 on any of the preamp valves anymore. So we'll just disconnect that. And then we'll desolder it from the chassis as well, and just clean up that patch where the solder was. So looking closely at these solder connections, there's a lot of solder on there. I think we might have the old leads left in every hole and just tack soldered on, so that, yeah, that's shit. That's shit. Whoever does this, you're not a tech, you're just a hack. So now we've got the problem of caps probably don't reach the original solder connections unless we just do everything half-assed like the previous dick face. I shouldn't say that, maybe it was the owner. I might ask him before publishing the video, eh? So yeah, we kind of need to clean all the holes. Everyone's got like an old little lead in there and a big blob of solder. So not as quick and easy as I initially thought, champions. As is always the case. Always, 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 always. There's more shit that you can never foresee. Every single job. That's if you do the job right and don't just put your blinkers on and ignore everything like every other bloke does. And I haven't even looked at the values of these caps too. I'll confirm that they're all as per the schematic as well. We'll basically remove all the film caps as well and reinstall them if possible. If not, we'll put a Mallory 150 in there. It just blows my mind how some techs think. Like, sometimes they seem to go out of their way to make life difficult for themselves, you know. It's easier to do the job right. But as the owner of this thing said, do it as if it was my own amp. So, no blinkers. Do everything properly. You've got peace of mind for the long term that way. So here was me looking at the caps thinking, oh, not a bad job, he's kinked the leads and stuff for strain relief. But yeah, when you look closer, there's always something silly. These tweezers are a little bit light duty for this job. I think I need my needle nose pliers. Yeah, so when customers say, oh, this other tech will do it for half the price of you, well, you know why. You gotta laugh. Oh, Choir Boys is on the radio. Genie! Love Choir Boys. I had that song, baby, stuck in my head for a whole year once. Alright, champions, she's looking pretty naked. So I don't think you want to watch me clean out like 50 eyelets. So I think we'll leave this one here. I'll get it to the point where we're ready to start constructing everything again. You know what's got to be done, and we'll do a video on the reconstruction process. So I'll catch you on that one, legends. Take it squeezy. Give us a thumbs up or two, you know, and share it around. Spread it like butter, as they say. Zebras, zebras, zebras. So catch you on the next one.